Hello everyone. The topic in this video is bond parameters, part 1. Under that we will be discussing bond length. But before we pass on to the video, I am Anandavalli. I welcome you all to this new video from Guidance Education channel. Please watch the video completely so that you get all points clear, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Okay, we already know what bond is. Bond is the force of attraction between two atoms which hold the two atoms together. Parameters means features. So we may also say features of bond. Bond has several features. One such feature is bond length, that is length of the bond. This parameter tells us the distance between the nuclei of the participating atoms. Bond length is really the distance between the centers of the nuclei of the two atoms participating in the bond. Bond can be covalent bond or ionic bond. Now here we are taking covalent bond. In the case of covalent bond is formed when two atoms share electrons. When one pair of electron is shared, it forms a single bond. When two pairs of electrons are shared, it forms double bond. When three pairs of electrons are shared by the same atoms, then it becomes a triple bond. Anyway, let us first consider the single bond. If you consider a molecule of chlorine, that is Cl2, this is the nucleus of atom number 1 and this is the nucleus of atom number 2. The distance between the centers of the nuclei of these two atoms is what we call bond length. See the diagram? It is this length which we call bond length. The boundary of the two atoms which are attached like this by this bond can be represented more clearly like this. Then this is the bond length, the distance between the centers of the two nuclei. This is the bond length. Bond length is very specific for each type of molecule. That is, say molecule of oxygen, molecule of hydrogen, molecule of water and so on. Each of them have specific bond lengths. The bond length will differ from one type of substance to another. So that is one basic feature. Indirectly, it means that bond lengths in one particular type of molecule will be constant, or different molecules can be identified from their bond lengths. How is this bond length measured? It may be measured by three different methods. One is spectroscopic method. Second one, X-ray diffraction. Third one is electron diffraction. Electron diffraction. You will learn more about these techniques in higher classes. For the present, we will just mention this procedure. So, using any of these procedures, bond length can be measured. What is meant by covalent radii or covalent radius? Let us represent it by the symbol small r, small a. Covalent radius is measured approximately as the radius of the atom's core, which is in contact with the core of the adjacent atom in the bonded condition. Please note the fact it is in the bonded condition. Consider a molecule made up of two similar atoms as in the case of chlorine molecule. In such cases, the covalent radius is just half that of the bond length. So Ra is equal to half bond length. The atoms are similar. Remember that. What is van der Waals radius? Represented as small r v small d w. Van der Waals radius represents the overall size of the atom, which includes the valence shell in a non-bonded situation. So for that, we have to consider two molecules. This is chlorine molecule number 1. This is chlorine molecule number 2. We consider these two atoms which are not bonded. If you consider these two, they are bonded. These two atoms are also bonded. So we consider this atom of one molecule and the other atom of the other molecule. These are not bonded. Chlorine exists in the gaseous state, so there will be a very small gap between the molecules. So the distance between the centers of the two nuclei belonging to this concerned atoms, one belonging to one molecule and the other belonging to the adjacent molecule, is considered, and half of that distance is the van der Waals radius. Let me explain the difference between covalent radius and van der Waals radius. Covalent radius is half of the bond length in the case of a molecule formed between two similar atoms. Van der Waals radius is half of the distance between the centers of the nuclei of two atoms belonging to adjacent molecules. Consider a molecule formed between two dissimilar atoms. One is small and the other is slightly large. These are their concerned nuclei. The small atom is marked A and the big atom is marked B. Here also, the distance between the centers of these two nuclei will be the bond length. In this case, half of the bond length is not the covalent radius because the size of the atoms are different. So, a line drawn between the cores of the two atoms which are in contact, it will not be exactly half. The covalent radius for atom A will be smaller than the covalent radius for atom B. But in both cases, that is irrespective of whether the participating atoms are similar or dissimilar, bond length is equal to the total of the covalent radius. In the case of van der Waals radius, the atoms belong to two different molecules and the concerned atoms are not bonded. When we consider the bond length in the case of multiple bonds, length of the single bond is greater than that of double bond than that of triple bond. That is, the bond size goes on decreasing from single bond to triple bond. So as the bond number increases, the length decreases. So that also has to be remembered. I hope I was able to clear your doubts. If you think the video is useful, consider subscribing my channel. Thank you very much. We will meet in the next video with another important topic like this. Till then, bye. Take care.